Hi, I'm Hylke and welcome to my World Machine tutorial series. Today we will be taking a look at the erosion devices in World Machine, being the erosion, thermal weathering and coast erosion device. This will be quite a long episode as there's much to cover, so feel free to watch it in parts if that suits you better. All the devices can be found in the Nature tab. We will start off with the erosion device. It is one of the core devices of World Machine and a very important tool when creating terrain, used in almost every world. It allows you to create realistic hydraulic erosion, meaning that it simulates years of erosion due to water hitting the terrain and carrying small bits of rock with it, depositing it somewhere down the stream. What we get is carving and channeling of the terrain, scraping away some features and in return creating large patches of sediment elsewhere, where the crumbles of rock accumulate over time. Before delving further into it, we should first create a bit of interesting terrain. We will begin with an advanced purlin and connect another one to its distortion guide to give it some rougher features. Then add a terrace device and we will also add some modulation to it using another advanced purlin. And finally, we will connect the output of the terrace device to the erosion device. We immediately see the terrain drastically change, but let's unravel the true power of this device. When we open the properties, we see quite a modest number of parameters, just 5, but that's because a lot of it is hidden as advanced settings. Let's open those as well, and now we're greeted by an intimidating list of 15 parameters. But as you may have noticed, the top 5 haven't changed, and those are truly the core parameters of the device. The most important and determining parameter is the duration slider. This determines how long the erosion simulation will run and therefore how much effect we will see. The default is 100, and when we decrease its value, we see the erosion effect wanes until there is nothing left. And of course, the effect intensifies if we increase the value. Let's set it to 100 again and go to the next two parameters. The rock hardness and sediment carry amount parameters can't really be discussed separately as they are so intertwined. The rock hardness determines how easily the terrain can be eroded away, whereas the sediment carry amount determines how much of the terrain will be eroded away. Increasing the rock hardness will counteract the effect of the sediment carry amount and vice versa. So instead of talking a lot, let's move some sliders. When we move around the rock hardness, we see the terrain losing a lot of shape when we decrease its value, whilst it will remain untouched if we set it to the max value. If we now were to change the value of the sediment carry amount, we see it has no influence at all. Let's set the rock hardness to 0.5 instead and see what happens if we move around the sediment carry amount slider. If we increase the value, we see the terrain gets eroded away more and more, and if we decrease its value, the amount of erosion is reduced. So this parameter truly determines how intense the erosion is. How much it can erode away is determined by the hardness of the terrain. The next parameter is the Geological-time enhancement checkbox, which enables or disables the 4 underlying parameters. The first of those parameters is the erosion time intensifier, and this is also the last of the core parameters that is visible if we disable the advanced settings. This slider can be seen as an overdrive for the duration parameter, and it will increase the perceived duration of the simulation drastically, without increasing the render time by the same amount. However, it can cause some artifacts, which brings us to the next parameter. The reconstruction type parameter lets you choose how to fix up the artifacts caused by the erosion time intensifier. The default, better or smooth ridges, creates a more true to original result at the cost of extra render time, whilst the fast or linear ridges option is a lot faster but can create a distinctively different result from what you'd expect and is prone to straight line artifacts. I recommend setting it to the better option. The uplift parameter is needed when you have a water system in your terrain. So let's add a flow restructure and create a water device to the world and connect the water system output to the water channel mask. The Erosion-time intensifier is not really aware of the water system and will erode the terrain around the river and water away, especially for higher values, creating for some very unnatural looking situations, as you can see. The uplift parameter is a clever way to lift the surrounding terrain, ensuring the rivers and lakes are bedded into the terrain again. Do note that this feature drastically alters your terrain, and I recommend to do the heavy erosion of your terrain before adding a water system to avoid this. For now, we disconnect the water system again. The flow sediment mask structure is the last one of the geological-time enhancement parameters. It controls how much sediment flow of the erosion-time intensifier is averaged across the map. When set to 0, almost no averaging of the result is done, which leads to a grainier and more detailed look. When increasing its value, the averaging strength increases, and at 1, the sediment flow is averaged across the entire terrain, losing a bit of detail. It is especially useful to influence the characteristics of the erosion device it masks, as the averaging of the values is noticed a lot more in those than you can see here in the terrain. Next up are the flow filtering parameters. These parameters control the post-erosion filter applied to the terrain. The first parameter is the filter type, which lets us choose between no filter, smoothing filter, and inverse filter. The smoothing filter reduces sharp edges and small peaky artifacts created by the erosion, acting like a locally applied blur filter. The result is a more smudged terrain with less prominent features. The inverse filter, on the other hand, emphasizes those sharp edges and carves them out even more, giving it a very specific and artistic look. Let's reset it to the smoothing filter and see what the next parameter has to offer. The strength of the filter is determined by the filter strength parameter. By default, it is set to 0.15, resulting in a bit of filtering when enabled. For the smoothing filter, this is quite a good all-round value. When we increase its value, we see the erosion features start to diminish and we get an overall smoother terrain, with more pronounced hill slopes forming, reminiscent of talus slopes. Now see what happens when we change the filter to the inverse filter. The terrain drastically changes and we get a very distinct shape with lots of sharp edges. When we set the filter strength to 0, we effectively disable the filter. Below the flow filtering, we have the channeling erosion parameters. Here we can set the parameters for the channeled erosion, which is a type of erosion method that tries to emphasize the carving of the channels. It does not mean that with this method only you will get channeling. The standard erosion method also does that. It just creates deeper channels than usual. It is important to note that this is, just like the flow filtering, more of a post-processing rather than fundamentally changing the erosion itself. It is also applied after the filtering and therefore can be used to bring back the channels that may have been smoothed out by the smoothing filter. The method parameter allows us to choose between standard erosion and channeled erosion, so for now let's set it to the latter. We can then manipulate the channel depth parameter, which determines how much extra carving should be done on existing channels. By default, it is set to 0.05, only carving a bit extra. When set to its max value, 0.125, the channels will be carved out the most possible, but quite often you don't see a huge difference between the two, especially if you have a high rock hardness value. The post-channeling erosion parameter lets us control if the erosion device should do some extra erosion afterwards to better incorporate the carved out channels into the terrain. The slider specifies the percentage of total erosion to be done again, so it will drastically increase your render time, as you can go up to 75%, almost doubling the render time. And that brings us to the final section of parameters, the options. These are compatibility options and allow you to let the erosion device behave more like previous versions, so it is not something that is often needed for newer worlds, unless you really like the old erosion behavior. The first option, preserve map borders, ensures that the borders of the map are not altered in height. This can come in handy when applying erosion to a chunk of existing terrain, but it does create artifacts if you perform strong erosion. For example, when using the Geological-time enhancement options as well. The hardness doesn't affect channel depth parameter, lets you override the new erosion behavior. After version 2.3.7, the erosion device carves out channels differently depending on the terrain's hardness, which is a more realistic approach than before. However, sometimes it can be artistically useful to have full carving power, and this option can help you with that. With all the parameters covered, let's move to the ports of the erosion device. It has 3 inputs and 4 outputs, quite a lot. The top input and output, however, are the obvious primary in and output for the terrain to erode, which reduces the number of ports to discuss to just 5. The inputs are especially useful to control the behavior of the erosion, and the outputs provide an interesting basis for texturing. The second input, hardness mask, lets you alter the terrain's hardness on various places, which is very useful to create more diverse and realistic erosion. Let's connect a gradient to the port and see how it behaves. Immediately, the terrain looks a lot more eroded, and that's because the mask will tell the erosion device the terrain only has its full hardness if the mask is at max value. The maximum hardness is still determined by the value of the rock hardness slider, so it probably becomes clearer if we increase its value to 1 and reduce the width of the gradient. We now clearly see that, on the left side of the terrain, the hardness is a lot less compared to the right side of the terrain. You could also use the height of the terrain to drive the hardness of the rock, for example, by connecting it to the output of a select height device. The water channel mask input is a special input, as it accepts both height maps and water systems. As demonstrated, it can be used to incorporate existing water into the erosion, and the algorithm will treat the water as an endless pit in which it can dump as much sediment as it wants. The result? A lot more erosion near those areas and a reduced buildup of deposition. Let's copy the erosion device and we will connect it to the earlier created water system. When we compare the two erosion devices, we see the one with the water channel mask connected has a lot less deposition of sediment around the rivers than if we were not to connect the water system. It works a bit differently if we use a height field instead, which we can see using the same gradient as before, but we set its width to 0 meters. Set the rock hardness to 0 and the sediment carry amount to 1. When we take a look at the result, we see a clear difference, with on the left a lot of sediment dispositions, whilst on the right we see none. Knowing this, you could effectively use this as a mask for the erosion effect, but I recommend using the proper mask port for that instead. And now for the outputs. The first one to discuss is the flow mask. This mask tells us where and how the water that caused erosion flowed down the terrain. The intensity of the lines determine how often water flowed down that path. The where mask shows where rock has been eroded away, and again, the intensity of the mask tells us the intensity of the erosion. Especially the carved channels will have a high intensity. Do note, the mask is normalized, meaning that the intensity only tells you how much has been eroded away relative to the other parts of the terrain, but it tells you nothing about the amount of actual erosion. The last output, deposition mask, shows where the sediment has been left on the terrain. Just like a wear mask, this is a normalized mask and doesn't tell us how much actually is deposited. And that's it for the erosion device. Quite a lot to discuss, and don't be worried if you still don't understand every aspect of it. It will take some time to process all of this information, and in the end, the best way to get a proper understanding is to play around with it. Before we go to the next device, maybe pause the video, stretch your body and give yourself a bit of rest, and then we'll continue. The next device to discuss is the thermal weathering device. This device is also an erosion device, but instead of using a simulation of hydraulic erosion, it simulates the fracturing of rocks caused by thermal stress. An example of this is water getting stuck in cracks and expanding when it freezes. That force can then fracture the rock and a piece falls down the slope, creating a talus slope, essentially a big pile of rocks. The effect is a reduction of rock at the top of the slope or cliff and an increase in talus at the bottom. We can use the same terrain as before, but I will reduce the number of terraces ever so slightly as the effect is more pronounced near steep areas. When we open the properties and also show the advanced settings, we see it has a total of 6 parameters, all sliders, making it a lot more comprehensible than the erosion device at first sight. The first parameter, talus production, controls the amount of talus created by the effect, similar to the sediment carry amount parameter. By default, it is set to 1, producing the maximum amount of talus. When we decrease the slider, we see the talus is reduced and the rock at the top is reduced less in height. The angle of repose parameter determines the angle of the talus slope. Its name is the scientific name for the steepest angle of descent a granular material can have relative to the horizontal plane to which the material can be piled without slumping. That is quite a mouthful, and it simply means the maximum angle of a hill of a certain material. And that is something to keep in mind when using the thermal weathering device. Gravel, or crushed stone, usually has an angle of repose at around 45 degrees. But if it's mixed with sand, its angle is reduced to around 25 to 30 degrees. Sand alone, then again, has an angle of repose of 34 degrees. So when creating a sandstone terrain, you should aim for a different angle of repose than for a terrain with a lot of granite, if you want to be accurate. Something else to keep in mind is that changing the value will also influence the overall talus production, as you can see when we decrease its value. Let's set it back to 33 degrees. The fracture size determines the average size of rock chunks that are eroded away. Changing the value can lead to some more chunky, rigid slopes or cliffs, but it is quite a subtle effect. The talus size, on the other hand, is quite a noticeable effect and is the average size of rocks that are part of the talus. Imagine these rocks to fall down a cliff and break into smaller bits on impact. The thermal weathering device will emulate this by adding a rough talus-like noise pattern to the talus. When set to 0 meters, the effect is disabled. For quick preview purposes, this emulation can be a handy feature, but I recommend against using it if you want to have some more control over the final talus. For example, if you were to import this into a game engine, you can add rocks by yourself on this slope to create a better, higher detailed talus, instead of relying on the, well, ultimately lower resolution mesh of the terrain. Or if you use materials, you are better off creating a rock material with a good normal map, which can have a lot more detail as well. The simulation length parameter determines the duration of the erosion simulation, just like the duration slider from the erosion device. The longer the simulation runs, the more rocks are fractured, the further away those rocks can fall, and the larger the talus can become. By default, it is set to 50, which is a good compromise between a nice result whilst not taking up too much render time. The final parameter, intensity, is a multiplier of the simulation length, kind of like the erosion time intensifier. But unlike that one, this time around, the simulation is properly multiplied and therefore it will take a whole lot longer to simulate. You could in theory do a simulation of 600 cycles, but that will take an awful lot of time to render. I almost never use this parameter and I recommend you to leave it alone if possible. Just like the erosion device, the thermal weathering device has quite a lot of ports. What is peculiar is the lack of a mask input. This is because of how the taluses are generated by the device. So instead, we get a talus production mask, which allows us to tell the device where we want talus to be produced and where not. As you've probably guessed, let's use a gradient to see how the mask behaves. We set its width to 0 meters, and also set the angle of repose to a lower value to exaggerate the result. And immediately we see a difference between the left and the right side of the terrain. Note that the created talus does go outside of the masked area. Again, this is because although the production of the talus only happens within the mask, the falling rocks can roll outside of the mask. The other input, talus removal mask, allows us to remove the generated talus in certain parts, but again, it tries to respect the naturally generated taluses. What is interesting, just like the water channel mask port, it accepts both a height field and a water system. These areas will now soak up the generated talus and the underlying terrain's geometry will be preserved. This is useful if you add the thermal weathering device after you've added rivers or roads. The talus mask output tells us where taluses are created, which is useful for texturing. The talus depth output tells us how thick the created taluses are, which, again, is useful for texturing if you want to blend different types of terrain. And that's the thermal weathering device. It is a nice complementary device to the erosion device and gives your terrain a lot more of a natural look without too much of a hassle. And that brings us to the final device of this episode, the coast erosion device. This device is a bit different from the other two as it has little to do with erosion and is an awful lot faster. But before we dive into its properties, we have to alter our terrain a bit by connecting a gradient to the Advanced Berlin's shaping guide. If you are on an older version of World Machine and are not seeing any water, add a scene view device and connect it to the coast erosion's primary output and water output. Then lock the preview and you'll be able to see the water as well. When looking at the properties, we are greeted by 4 sliders and a button. Not too much going on here. The first parameter, sea level, determines the height at which the sea starts. It goes from 0 meters to the max world height. When we move it around, we see not only the water moving up and down, but also the terrain being reshaped. The button Set Water Level to Guide will set the value of the sea level parameter to the value of the sea level parameter from the Display Guide section, which can be found in the project sidebar. This can come in handy if you had already had a sea level in mind whilst concepting your world and used the display guide for it. The beach size parameter controls the sizes of the beaches and how far into the sea they reach. To see this clearer, we focus our preview on the primary output. By default, it is set to 127.5 meters. When we increase the value, we see the beaches crawl into the sea, and the opposite happens if we decrease the value. We can also affect the land near the beaches with the Inland Height Influence parameter. This will reduce the height of the terrain near the beaches following a smooth step fall-off. You can recreate this effect using a clamp and a select height device, but I'll leave that as a challenge for you. To me, the effect of this parameter alone is a bit dull, and I recommend mixing it with, for example, a terrace device to get some cliffs. The last parameter, Underwater Smoothing, will smooth the terrain that is underwater, giving it a more seafloor-like character. It goes in steps and has 6 steps in total, each one gradually adding more blur. The coast erosion device also has a number of ports, especially outputs. The beach map input tells the device where the beach can be created and where it can have inland influence, giving you a more granular control over these 2 aspects of the device. When we connect a gradient to it and, again, set its width to 0 and rotate it 90 degrees, we see that on one side we do get beaches and some reduced height inland, whilst on the other side we have neither of those. The water output exports the water system created by the device, which represents our sea. Additionally, it has an output for the water mask as well, which comes in handy when texturing or when altering land masses and you don't want to disturb the seas. The beach mask shows where beaches are added, again useful for masking and if you want to leave the beaches untouched by further terrain processing. And finally, the water depth output, which is nothing more than a height field encoding the depth of the water for each pixel. And that's the Coast Erosion device, a very simple but useful device to quickly generate beaches next to a sea. As it is not the most complex device, you can create a macro that does the exact same thing, which is a good exercise and a fun challenge. And that brings us to the end of this long episode. I hope I haven't overwhelmed you too much with all the information, and I hope you've learned something. If so, maybe leave a like or even subscribe to the channel. See ya!